Hey everyone, and welcome. Today, we're going to pull back the curtain on the invisible world of chemistry that's happening all around us all the time, in your kitchen, in your bathroom, even inside your own body. So let's jump right in. So let me just start by asking you a question. What in the world could a car battery, a sour lemon, and a bar of soap possibly have in common? I mean, they seem totally random, right? Well, stick with me for the next few minutes, and you'll see the answer is all about their fundamental chemistry. So, here's our game plan. We'll start off by finding some chemistry right in your kitchen. Then, we'll get to know our two main characters, acids and bases. After that, we'll figure out how to measure their power using something called the pH scale. See what happens when they meet, and then wrap it all up by understanding why this delicate balance is so incredibly important for, well, pretty much everything. All right, first stop, your kitchen. Now, when you think chemistry, you probably picture some scientist in a lab coat, right? With bubbling beakers and all that. But nope, the real action is happening right in your own home. Acids and bases, they aren't some exotic chemicals. They're literally the building blocks of our daily lives. And I'm not kidding, they are everywhere. You know that little tartness in your salad dressing? That's an acid. The cleaner that just magically cuts through grease on your stove? That's a base. And the reason you can even digest your food in the first place? You can thank a super powerful acid in your stomach for that. So let's properly meet our first chemical character, the acid. Now, I want you to think of acids as the givers in the world of chemistry, and you're about to see exactly why. Okay, so here's the official definition. When you put an acid in water, it gives away or releases these little things called hydrogen ions. That's the H plus symbol you see there. This one action is the defining feature of an acid, and it's why they always measure less than 7 on the pH scale. So how do you spot an acid out in the wild? Well, for one, they often taste sour. Just think about the pucker you get from a lemon. They can also react with metals, which is why you probably shouldn't store tomato sauce in certain metal containers for too long. Plus, they can conduct electricity, and especially the strong ones, can be pretty corrosive. And this just shows you the incredible range we're talking about. We've got weak acids we eat all the time, like the citric acid in lemons, but then our own bodies produce incredibly strong hydrochloric acid to dissolve our food. It's the same chemical family, just wildly different power levels. Now for our second character. You know, every hero needs a good counterpart, and for acids, that role is played by the base. Let's find out what makes them the other side of this chemical coin. A base is basically the chemical opposite of an acid. So instead of giving away hydrogen ions, a base either accepts them or it releases something called hydroxide ions. That's the OH minus. This makes them the perfect chemical match for acids, and it's why they always measure more than 7 on the pH scale. And their properties are totally different too. Instead of sour, bases usually taste bitter. And here's a really memorable one. They feel slippery to the touch. You know that slick feeling you get from a wet bar of soap? That is a classic sign of a base doing its thing. And most importantly, their superpower is neutralizing acids. And just like acids, you don't have to look far to find bases. They're all over your house. The soap you wash with, the ammonia that's at a lot of window cleaners, and of course, that trusty box of baking soda sitting in your fridge. All fantastic everyday examples of bases. Okay, so we've met our characters, acids, and bases. But how do we actually measure just how acidic or basic something is? Well, that's where the pH scale comes into play. You can think of it as a power meter for chemistry. It's really just a simple number line, running from 0 all the way to 14. Anything below 7 is an acid, anything above 7 is a base, which you'll also hear called alkaline. And the rule is simple. The further you get from the middle, the stronger it is. And right there, smack in the middle, at number 7, we have perfect neutrality. This is the ultimate balance point. And the best example? Pure water. It's neither an acid nor a base. It's kind of like the Switzerland of chemistry. This chart here really helps put it all into perspective, doesn't it? Way down at the bottom, around a pH of 1, you've got super strong stuff like battery acid. Lemon juice is around a 2, then you hop over neutral water at 7, and you get to soap around 10, and way up top, you have powerful household bleach at a 13. Now here's the most important thing to get about this scale. It's not a simple one-step-at-a-time scale. Every single whole number you move is a 10 times jump in strength. So that means lemon juice at pH 2 is 10 times more acidic than something at pH 3. And battering acid at pH 1, that's 100 times more acidic than that pH 3 substance. It's a massive leap. So what actually happens when these two opposites,
An acid and a base finally come face to face. Well, you get a chemical reaction called neutralization. It's the great balancing act of chemistry.
It's actually a beautifully simple process. An acid and a base react, and their opposite properties literally cancel each other out. The hydrogen ions from the acid grab onto the hydroxide ions from the base, and they form, you guessed it, water. And what's left over combines to create a salt, which in chemistry is a whole category of compounds, not just the stuff on your French fries. And here's the perfect real-world example of this. Have you ever taken an antacid for heartburn? Well, heartburn is just what happens when you have too much stomach acid. That little tablet you take, it's a mild base. It goes into your stomach and performs this exact neutralization reaction, calming down the acid and making you feel better. It's chemistry in action, right in your body.
So why does any of this matter beyond a high school chemistry class or soothing an upset stomach? Because it turns out that maintaining the right pH balance is absolutely critical for life as we know it, from our own bodies all the way up to the entire planet. I mean, take your blood, for instance. It has to stay in this incredibly tiny, narrow range, right around a pH of 7.4. If it moves even a little bit, your body's systems just start to shut down. In the environment, acid rain can mess up the pH of lakes and soil, damaging whole ecosystems. Farmers are obsessed with soil pH because it's crucial for growing crops. And hey, if you've ever had a pool, you know you have to constantly manage the pH to keep it safe. This balance is everything. Which leaves us with this one final thought. From the acid that helps us digest our food to the base that helps us clean our homes, these chemicals are essential to our lives. But in the wrong place or at the wrong concentration, they can be incredibly dangerous. And it all comes down to that one little number on the pH scale, a simple number that holds all the power of chemistry and the real key to balance in our world.